All right, let's get back to it. I had to deal with some stuff. All right, so we wrote a test. We got a test running. This horrendous piece of software. This gigantic piece of code. All right, so what do we want to do? What do we want to do? So what can we do? I mean, we can resolve things. That's cool. Okay, I know what we need to do. We need to check. Let's write another test. Um, Two passes. These tests are gonna be like not useful one day. So I'm just sort of like copying and pasting this stuff. So we want let's call it two iters. Okay. Um, we're all good. We're working. All right. So basically, we want all right. So with the resolution with two iterators. So like really what this test is gonna do. So last test was basically, okay, we define height using some sort of scale, like using a float, and then we calculate with using the height constraint. So if it's 100, it should be 200 because 2 height multiplied. Okay, let's flip that. Let's put width in front of height. You know what? I'm just gonna do this. I'm gonna do auto expert size equals static cast stood uint 16t star and then null pointer. Okay. I'm sorry. You know what I mean. I'm a C++ guy. Like, it is what it is. It shows. Is that a lot to write to get just an empty point? Like, maybe, I don't know. Um, I don't know. I don't care. I don't care. Okay. Auto. So we have the expression size and then ledger. What is ledger? Ledger is just a stood size t. I mean, come on. I'm using stood size t. That's hard. You know what I mean? I'm an STL disciple, I guess. You know what I mean? I'm like it's like CJ and then it's like me. STL disciple. Um, what am I doing? Okay. Alright, so we don't need to redefine those there. So that means, makes it easy to move it around. Okay, so if we run this, if we do this in one iteration, this won't work, right? Because width requires height, and height is not resolved yet. Because we haven't even set a value to it. By default, it's not resolved. So this should not work. Let's run it. This shouldn't work. If it works, that's a problem. Okay, it failed. Right? It's two. I mean, technically, it's like a I guess we should probably check the Should we do something like this? Expect true quad dot resolve mask and quad mask width. Can we just let's do it for height? Let's do it for I could probably reorganize this. Okay. Okay, so this will mean, resolved and so out buffer. So the first problem, right, is let's see, out buffer dot. Oh wait, we're in the wrong thing. Out buffer dot place back. Okay, so this happens. I don't think we need the dual window. So this happens, right? Like every single time, every new element, we want it in place. So but we only want to do this if it's the first iteration. So like, I mean, really, what we should do, I mean, this might be naive. I'm just gonna say if I equals 0, we want to add to it, and then, yeah, right? Okay. And then what we should do is we should say, auto out idx start with 0, and then probably at the end. Okay, so that way we don't need to like do some like, that way we kind of keep this variable around all the time. It just increases, it always resets to 0. This is the index in the out buffer, and we're only appending to the out buffer when we actually are we're only appending to the out buffer when on the first iteration, on the first pass. I don't love this because this is just sort of like another case where it's just like, I don't know, I hate code like this where it's just like, just write like this. To me is just like, why don't you just write 2 different loops? But I mean, that's not even, see, and then you catch yourself and it's just like, well, why don't you just do this? And it's like, why don't you? Like, that's actually not a horrible idea, right? This all could be put into some extra function, and then that way, you know, like branch prediction works perfectly. You know what I mean? Like, theoretically. Again, I'm not like, you know, this is just what I've been told. This is just what I hear. Like, you could have like the first iteration, like first iteration loop, and then rest of iteration loops. No branches. I mean, we've got this branch here. Yeah, again, this is like splitting hairs, but I find myself like writing code like this where it's like something has to happen on a certain iteration, whether it's the first or the last, and it's just like, it doesn't feel clean to me, and I just don't know the right solution, because also like creating like 2 loops like kind of makes it unreadable. It's like, okay, really, what's the procedure here? We actually want to go over each. We want to run, you know, 2, in this case 2 passes of the constraint solver. Why would it be 2 different loops? You know what I mean? So it's just like, I guess I'll just keep thinking about a better way to handle specific iteration logic. I don't know. Maybe there's a better way to do that, but yeah, I'll talk to some people. I'll get some feedback or whatever. Okay, so we have out buffer and place back. Okay, so our the first problem should be solved, and I know. And see, now this is this to me is like, ooh, right? Oh wait, no, this worked. Wait, I'm tripping. Cause this actually just worked because I forgot we actually set it to 2 iterations. So it worked. And it should fail if we set it back to 1. We should probably have a test to ensure that it does fail. I'm not gonna do that though, because, you know what I'm saying? Like, come on. Let's go. The chosen one. Highly favored, highly blessed. The chosen one. Highly favored, highly blessed. Okay. Top notch. Everything is top notch. Alright. Oh shit. Ooh, don't look at that. I mean, it's just chat. You know what I'm saying? Alright, All right, with resolution 2 iterations. Okay, I feel pretty confident that the constraint solving works. There are ways to optimize this for sure. There's way, like, we could maintain a list of like the things that are not solved. I don't want to do that yet because I don't think that that impacts how we build the rest of this. Like, I do genuinely think having the flat buffer of everything is the way to go. And whether we're iterating from uh top to bottom, or like, jumping down, like jumping down is faster, but it's like you don't need to, like, it might be faster because also just like, evicting things from cache and stuff, like we don't actually know, but you actually are doing less work on the CPU because like you're doing less actual calculations, because like I'm like recalculating every single pass. Okay, yeah, eventually this is gonna be this is good. I'm not explaining this very well, but like all this like all of this stuff gets run every single time on every single pass, whether or not it's like whether or not it's solved. And that could actually, I don't know. I'm gonna leave it. That's not, you know what I mean? That's none of my business necessarily. It is my business. It's my UI library. But okay, that's good. Now, all right, I'm getting rid of this because I already explained that. All right, so we have the iterations and we have some form of resolution. Okay, now I think, do I like this code? That's really the question. I really like this function. This function's so, like, look at this. And look at how I have it formatted too. Like, people, like, you know what I mean? People spend their whole lives trying to write like good, clean code. Look at this. Default theme, like, it's just, I mean, this is just beautiful. It really is just beautiful. Like the spacing, I mean, this is so readable. This is so readable. You know what I mean? I'm like, I drank the STL juice. I have like stood no opt. You know what I mean? I'm not returning some magic value. It's just stood no opt. I'm returning an optional. Like, that's super cool, I think. Like, I think anytime you can sort of like use the optional and you're not like shoehorning it into your use case, like, it's like pretty rare that this is like useful in my experience. But honestly, you know what? That might change. I think, like, honestly, like, this makes more sense than returning like a tuple, or like, doing like a bool okay type situation. I mean, they, like, it's places I work where they do that, and it's just like drive me up the wall. So I know it was the truth. It was the method at one point. I did do this. I can take that out. I don't even, like, what? If you can't understand that, like it literally takes one click to go look at that function. Okay. Eval quad field. Okay. We just wrote that. All right. I think it's time to look at how we used to do layout. Because I think actually there's this file. Nope, not DSL. Jeez, what? Why do I have all this open? How do I close all the tabs? I don't want any of this stuff. Jesus Christ on a stick in the heat of July. Okay, I feel like such a noob. Okay, whatever. We got some tests. Those tests are atrocious. I mean, obviously, like, my instinct is like, oh, let's write a clean API, but let's finish with the solver. Okay, let's finish with the solver, because there may be things that we haven't considered. because there's a whole world of layout and like element like there's more constraints, and then there's the concept of like a repeating uh widget, or like a repeat, like a repeating element that all of its children are, that's part of one layout that just repeats. So like that could be very useful in like a list where it's like we only want to actually display, we only want to like actually like create 7 or so rows in memory, right? um and render those, because like you could have a 10,000 rows and we're not going to create all those rows, right? Like that'd be preposterous. Like, so we really only want to have like 7 or 8, but you need to know your parent size in order to know how many rows to add. And like that kind of breaks the declarative sort of model where it's like, okay, you declare your parent and then you declare a list of children, and then you know you want to declare your like layout for that. It's just like, but you don't know the height of your parent necessarily in the declaration phase. You don't know how many children to add. So it's like really what we should have is like another element type that is just like a repeater or something like that um yeah, I don't know exactly what to call it. We'll get there. It's definitely coming up, but we gotta get through this layout stuff first, because like honestly this is like kind of the most annoying part, because this part changes, right? So before Jesus, I hate this like auto documentation stuff, but whatever. So like before it was like you'd have like quad, you'd have like begin layout, you'd have children, and then you'd have like end layout, and end layout would inform quad, but it would also begin layout would have some information about your layout. And now this is all back from when the like paradigm v1, like paradigm v0, really like when I was trying to make it all just one, like a single pass, just one pass. Because and you can actually get a lot done with this. Like really do not sleep on this method if you really need one pass, because I'll tell you why. So you have basically like quad, the stuff, let's say top left, so where the children get laid out, but quad expands vertically to fit its children. Down here, you have a pointer to quad, and you know how tall all your children are, and you knew where to start drawing them, so you know the height of quad. In this case, I don't want to do it that way because we're not constrained. It's like there's so many like common layouts. Like let's say you want something that is like variable width, and then you want to center something within that width. You need 2 passes. There's no way about it. Like that's more common than you might think. There's like plenty of reasons to like have multiple passes. So I think like it should be assumed that there's already going to be 2 passes. So that's why I'm okay doing something like quad layout children. That's it. Once we we have our stack, right? Once we pop something off the stack, if that's a layout, then that layout gets ended. We know because every time we go to the next element, we might end up we're manipulating the stack, but we might end up popping some layout off the stack. So layout, that's why like if you saw like stack entry just being an index, like it has to have some like layout state, or like I call it like layout, like, or like maybe even like layout context, just to like keep going with the theme. Again, like naming is just something I really struggle with. I really don't want to get stuck on it today. So I'm just sort of like whatever. Okay, so stack entry. Okay. So what should be in the layout context? Okay. Struct layout okay, so what there is a layout state. Yeah, see, this is what we want, I think. Alright, so it already has a layout info. So a layout context and I don't want to start with this. What I want to start with is what information we need. So we start off with like eval quad, and then let's say eval layout. Let's make a function for that. Inline auto eval layout. Solve context. Okay. Eval layout. So what do we need? We need layout direction, which could be right, down. I think that's all we support right now. Really what this should be is layout type, and it should be like row, column, no, because also think about it this way, right? Layout direction actually does matter, right? Because what I'm thinking about is like, what if you have like a grid layout? You could, I mean, first of all, you could have a row that grows to the left or to the right. You could have a column that grows up or it goes down. You could have a grid that expands up. You could have a grid that expands down. And I'm thinking from like a game UI perspective, like that actually could be useful. Like you could have something like on the bottom of your screen that grows up. You could have something on the right side of your screen that grows to the left. And so it's sort of like you have like a layout strategy, like row, column, grid. I think that's probably it, right? And honestly, I'm gonna take out grid. I really am. And I'll tell you why. Because honestly, you can do grid with this stuff. Like you could just have a row full of columns. You know what I mean? Like the logic for laying stuff out might be different. But that actually, right, like if you're displaying data in a grid, that's gonna fall more into like widget territory than layout, right? Because layout just takes things and puts them in a certain direction. Maybe we want a grid layout. Oh, man, there's a lot of ways to think about this, and like honestly, like I know enough that I don't have to like this is my decision, and that's where I struggle with a lot. Like this is really up to me. Currently we have just right and down, and I don't think I really might be overthinking this. I think I'm just gonna stick with layout direction because that can be right, down, left, up, and up and down imply column, right and left imply row. The API can change, but like this sort of makes sense. Okay, so we want a layout direction. Sorry. So like let's say ctx.in_buffer.reader.read layout direction. I think let's just use what we have. let's just use dir because we know we're evaluating a layout. We have a margin. What is a margin? I think it's just 1, 2, 3, so 4 float. Okay, const auto margin equals ctx in buffer read margin. Oh right, because I guess I have something else. I guess I have like builder functions called margin. I do kind of hate that. Whatever. That's another like annoying thing with like, you want it to be declarative, but like sometimes there is like naming collisions, and yeah, I don't know. I'll cross that. It's less important right now. Const auto spacing, I guess, is just a float. Like this is all stuff that is like user configurable. Moves ledger, I think is, yeah, because at this point we don't care about the element type. Moves ledger is sort of like, well, see, moves ledger is sort of like, does it affect the parent layout? So I think okay, so we have this, we have eval layout, so we're reading that stuff. I think, let's see, box element has a it has layout info. Okay, so that's pretty much what a user can specify. Okay, so that's the stuff we read. Okay, now this is like stuff that's coming in on the buffer. So these tests are automatically gonna fail, just because there has to be a layout, and we're calling this function now. So really what we should do is we should be calling like eval quad, and we shouldn't be like adding element types, like we shouldn't be calling this like master solve function to test this like individual functionality. Like, I think that's a good way to do it. To do write tests specifically for eval. Write tests specifically for eval quad rather than using main solve function. I think that's the way to do it, because like if we do that, like you can still use this context buffer. That's actually so genius, because you can use the context buffer. We could literally get rid of this. We could write height. No, because we need some sort of, well, we can add our own. We would have to push back on this. Like, we'd have to be like ctx out buffer dot, nope, push back, or sorry, place back. Yeah. Because the solve function is responsible for adding to this, so we would have to manually make sure that enough out buffers are there. I think that's okay. I think that's better than what we have. That maintains these tests so that they pass given this. Okay, let's not get distracted anymore. Okay, so we have eval layout. Layout. Alright, so we have layout info, and then we have layout state. And so layout state comes from, so we have quad. What we really need is, see this, okay. this is challenging because layout state needs expressions, right? All of these need to be able to be expressions, and that's dynamic, which means we need a dynamic, like we can't just have shoot. Like we might need to say instead of having this, like we might need to have like a buffer stack, and then some added mechanism to like pop oh shoot, well yeah, hold on, we might be shoot, okay, um hmm okay, let's not jump to this yet. We might not need it. I'm concerned because sort of the process is you go like you push stack entry. Okay. Then like this. You have some layout context. The layout context stores you're pushing, where are you drawing? Your top left. Where's the ledger? That moves as you add things to this layout. Where's your what's the actual like containing box? Actually no, we need this. Because if your ledger only moves down, what we probably realistically need is like I think these both need to be vec2s, and then to get a current draw position, we check direction, and it could end up being like top left dot x ledger dot y. But that way we're not storing redundant. I think this bounding box thing is redundant because we can extrapolate the bounding box from top left and ledger, which is bottom right, which really this should just be called bottom right. And then ledger, the concept of ledger, we could actually have just like a function to get ledger based on top left, bottom right, and function to get ledger based off of top left, bottom right, and layout. I'm just gonna say dir. We know we're talking about layouts. Okay. Okay. All right, that makes sense to me. Now, how do we implement this? How do we keep? How do we like? We're only okay. So the good thing is we're only modifying the layout at the top of the stack. We don't have to grow any memory, like, you know what I mean? The downside is, okay, top left never changes, but let's say bottom changes. That means we're shifting things down. We're shifting right down. So it's not like we're ending up having to move memory. We're ending up having to modify two things at the same time. There's gotta be a simpler way. We gotta be able to do this without that. That just feels too messy. It can't end. It does not end. It does not end here. Okay. Um. Okay. Hold on. Let's try. Let's vibe this out. And just FYI, when I say vibe this out, I do not mean vibe code it out. I mean like vibe code in this in like the 2010 sense, where it's just like, let me just like write some code and see what happens. Not like I'm some like Angular dev with like 3 brain cells who can't wrap my head around anything, and I need like a AI powered IDE to like make a landing page. That wasn't very strong. What I just said, that was not a strong burn. That wasn't a gotcha. I'm down. I'm down. I lost that one. You shouldn't lose that. You shouldn't lose battles to inanimate objects, and I just did. Is really what it comes down to. You shouldn't. Yeah. Okay. I'm all over the place. Okay, so we have this stuff. Now we want to do something with layout context. So by virtue of emplacing a new stack entry, can we just call it stack frame? Is that like fine? Is that like too specific? Look it up. I call it a stack frame. I don't. Whatever. Because actually it is sort of like function calls. This is sort of like a language, and we are sort of like. I don't know. Maybe I'm being too like conceited about this. Okay, so layout context. So we know where we're starting to draw. We know where we're starting to draw. And where we're starting to draw is where do we call this? We call it with the top left of. Okay, so we call it with. Nope. How do you go forward? Okay, whatever. Oh, it's copied for each invocation. I'm such a good part. Like all this like. Why did I? What is wrong with me? Okay. All right. So we basically need. Let's. Because we can't just have, we don't have an expression type. We have a buffer of instructions. We have a buffer of instructions. Maybe. Run with me here. Okay, so layout context. We have top equals quad dot top. Let's say expression quad dot top. It's very easy to test. Maybe we say something like this. Maybe we say top. Maybe we say if top if expert quad, I'm just referring to our if I mean, actually we could literally say, we actually could write this code. We could say if current ctx.current resolve mask, and all right, we'll start with left. That's fine. If this is the case, then we can say the layout context top or left equals ctx dot current left. And then we could say like ctx dot, I mean, maybe we just stick with using this resolve mask. Maybe not. I don't know. We might need to keep that information around. It's not the worst thing. It adds one more field. You know what I mean? To layout context. Should we horse around with this a bit? Cause like, let's just stick with left, because all right. So let's say left is not resolved. Let's say left is not resolved. Then, you know, then where do we draw everything else? Well, we say layout ledger dot left, or we have our constraint like op layout ledger x, and we can't do it. So it doesn't matter where these things don't have to exist. That's so okay. Hold on. I think we got it. Come on, stop, bro. I really think we got this. I actually think this could be way simpler than I originally thought. So layout context, we could say float left. Float. What order have I been doing this in? I think left. Yeah, left top. Float right. Float bottom. And then stood uint 8t. What did we call it for the quad? Resolved mask. Let's make sure it's 0. Like for sure it should be. You know what I mean? All right. It probably should. I actually don't know what the default value is. It probably should be 0. Are we at the right spot? Okay. I'm telling you, this shit stopped working like the first time I did this, but now it's like working. Okay. So if that's the case, then we can say, let's do something like this. Auto layout ctx equals ctx dot stack dot back dot layout ctx, and then we actually need to say layout context. Okay. Nope. It should be layout ctx to be clear. Okay. Now, if this is not resolved, we say layout if this is resolved, we say layout ctx dot left equals ctx dot current dot left. Layout dot ctx. That's it. Okay, what's an edge case for this? What happens? Oh man, what's an edge case for this? I had it. So what happens when you go from what happens when you need to know some? I think the idea is just don't evaluate things you can't evaluate, but evaluate things you can. Like, if we don't know left, but we know top, shit, we could just literally do like layout CTX. We could capture CTX and layout CTX. And then take in a I think let's take an std UNAT constituent mask, and then we can say, why is this complaining? Oh, okay, just clang tidy. Thank you, clang tidy. We could literally copy. This might be, I mean, this is probably fine. Mask. Oh. And then see, I don't love this, but I'm just doing this so I don't have to like copy and paste all over the place. And then field, we could say like float field. We float from field to fit. Now this is doing too much. I'm just writing it out. I really am. This is like insane. Width, quad mask, width. Like this would be like a macro thing, I think. I don't think. And then width. Oh wait, no. This. What we actually want, we do want to be able to know the size of it, even if we don't know where it is. No. Maybe we do want a bounding box thing. Jeez. Okay, hold on. This is a also, this is stupid. Like, why are we using a quad mask for something that's not a quad? Okay, let's start with this. Let's think about this a little bit. Man, I just don't know. I'm gonna take a break. Maybe go for a walk or something, because like honestly, like this is something I really need to like think through. I just don't know the right solution. I don't want to like I feel kind of unsure, and this is a lot to like write, so we'll come back to it. Thank you.